All right, and a couple more examples that we have here. We have a vase is sold in two sizes. We have a smaller vase and a larger vase, and these two vases are similar, meaning that this one is exactly the same size, or the same shape, I'm sorry, as this one. It's just bigger. It's a larger vase. And we want to find the height of the small vase. So we're looking for this value h, and we know that the two figures are similar. So we know that the ratio of the corresponding sides must be the same. And the two sides we know here are the bases of the vases. We have 4 here and we have 5.2 here. So whatever the relationship is between 4 and 5.2 is the same as h to 11.7. So we can set up a couple different ratios here. We can set up this ratio where we have 11.7 to h. The relationship from 11.7 to h is the same as 5.2 to 4. 11.7 to h is the same as 5.2 to 4, because 11.7 corresponds to h and 5.2 corresponds to 4. So this is a ratio or a proportion that we could write of equivalent ratios. Or we could write 4 to 5.2 is the same thing as h to 11.7. 4 to 5.2 is the same as h to 11.7. The smaller base to the larger base is the same as the smaller height to the larger height. Another proportion that we could write to solve this problem. Or another one we could write is kind of relating the side lengths of the same figure. So 11.7 to 5.2. Whatever the relationship is between these two values must also be the same between these two values because they are similar. So here we're setting this up a little bit differently than the previous two. Here we are setting up the relationships of the heights to the bases. So 11.7 to 5.2 is the same as h to 4. The height of the larger to the base of the larger is the same as the height of the smaller to the base of the smaller. And any one of these three are going to work out just fine, because if we do the cross multiplication for the top one, we get 5.2 times h. 5.2 times h is the same as 11.7 times 4. 46.8 comes from doing that 11.7 times 4. So multiplying these two together gives you 46.8, and multiplying 5.2 and h together gives you 5.2. Same thing with the second one. We can do 4 times 11.7. 4 times 11.7, kind of cross multiplying here. 4 times 11.7 is 46.8. 5.2 times h is 5.2 times h. And if we cross multiply the last one, 11.7 times 4, well, we've done that twice already. That's 46.8, and 5.2 times h is also 5.2 times h. So notice, doesn't matter which proportion that we use, we end up by cross multiplying with the same equation we have to solve for h anyway. And if we do that solving for h, we're going to get 9 by dividing both sides by 5.2. If we divide both sides of this equation by 5.2, we get 9. And then this is the same one, so we would get 9. So h is equal to 9, so the height of this vase is equal to 9. Doesn't matter which proportion we use, because they're all saying the same thing anyway. So the height of the smaller vase is 9. Last example is the flagpole problem, and we want to find the height of the flagpole without climbing it. Okay, we won't climb it then. So we're going to find the height of the flagpole without climbing it. And what we have here now, this is a little different because we have similar figures, but they're kind of overlapping, or they're on top of each other. We have this triangle right here where the height is the man, who is 6 feet tall. And then we have the distance right here, which is 5 of the shadow. And then the hypotenuse is kind of the line of the sun. So we have this smaller triangle right here. We have this triangle, and then we have a larger triangle. And the larger triangle is formed by the flagpole. So we have this height here. So the larger triangle is this entire larger triangle, I guess, that's right here. And we want to find the height of the flagpole. So we want to find this length right here. And we know that the bases of these triangles, the base of the larger triangle is 27 feet. It's told to us right here. The base of the smaller triangle is 5 feet. That's right here. We know the height of the smaller triangle, that's 6, and we're looking for the height of the larger triangle, which in this case is the height of the flagpole. So if we set up a proportion, we have the flag triangle here, and that's a 27, which you talked about there. So I'm kind of just taking this triangle out, and I'm sorry that, again, you can't see that, but it's there. This little thing right there is a 27, which we talked about. That's from right here. And then h is the missing value. And the smaller triangle, the dude triangle, this dude right here, his height is 6, and then this length is 5. And once again, you can't see it, but those are those two triangles we talked about. I just took these triangles and kind of separated them. So here's the flag triangle, and here's the dude triangle. And we know that these two triangles are similar. Well, we don't know that, but, well, they are similar due to the nature of what the sun would do by casting a shadow. So the flag triangle and the dude triangle are similar. So if we were to set up a proportion here, we would have h to 6. The height of the flag triangle to the height of the dude triangle is the same as the length of the flag triangle to the length of the dude triangle. So we have this proportion right here. Height of the flag to the height of the dude is the same as the length of the flag to the length of the dude. And then we have, once again, a proportion to solve by cross multiplying. We can do 6 times 27, and we get 162. H times 5, which is 5h, and then we solve this by dividing both sides by 5, and we find that the height of the flag is 32.4 feet. So 32.4 feet we put right here. So your target for today was to be able to use proportions to find the lengths of sides in similar figures. Your assignment for today is on page 311, and I want you to do 1 to 18, all of the problems, and the answers for all of those problems are on Moodle. So do not do just the odd. Do all of the problems, and the answers for all of them, including the evens, are on Moodle.